Section 4, we're just using more of the trigonometry, basic sine, cosine, and tangent problems, but we're going to be using it with talking about angles of elevation and angles of depression. Really, this is just looking at right triangles, but we're giving a name to the angle when we're using them in kind of a practical way. Angle of elevation is like if we're standing at a point and looking up. So elevation is thinking about looking up. And so that's going to form a right triangle because the ground or wherever just looking straight ahead would be one side, and then the altitude would be a 90-degree angle from that. So we would also have a line of sight from that. So one way we could use it, in this problem here we have an airplane that's wanting to take off. It needs to get over the mountain, which is 400 meters, and they ask us to have an extra 50 meters just to make sure. So what we're looking at in this problem is this side over here being 450 meters, and this side of it being 2,025 meters. And they want to know what angle is needed by this airplane here in order to clear that mountain. So looking at this angle here, this at A, this would be our hypotenuse, our opposite, and adjacent sides, so we want to use the tangent here. We could just put that into our calculator then, and that would give us about 22.66. They ask us to the nearest tenth of a degree, so it would be 22.7 degrees. The main thing we want to pay attention to here then is the angle of elevation was going from the ground and looking up. In this problem, we're looking at a flagpole casting a shadow. Now this will be a kind of common problem where we have some object, they're talking about a shadow, so that would be coming out this way, and we need to remember that that means we have a right angle here. So here's our flagpole of a height of 7.6 meters. Go ahead and draw the picture and label it. The sun's coming down casting that shadow, and on the ground we're measuring 18.2, and we want to find the angle here that it's making to go up towards the sun over here. So if this is our angle, maybe I can call this x here, then again we've got tangent. And often with angle of elevation problems we're looking at altitude in this, so they will often be tangent, not always. So the tangent of x will be the 7.6 over 18.2, and then we just solve it. Again, they ask for a nearest tenth of a degree, so pay attention for the accuracy that they ask for on these. Okay, the next thing is angle of depression. Now, if the angle of elevation was looking up, angle of depression is looking down. Think about if you're depressed, you are feeling down, you're looking down. So angle of depression is looking down. Now notice in this, if we're up here at the point B and we're looking down, if there was another person down here at A looking up, this would actually be the same angle. It's just that it depends where we're measuring from, and so we'll use different vocabulary for that. But then this angle of depression is always going to be equal to the angle of elevation, which is what we see on this page also. We're just, again, changing what we're looking at. We get congruent triangles here. So in this problem, we've got an angle of depression here, 10 degrees, which means we really should just put that 10 degrees over here and look up. Now pay attention to what we're asked to find here. We're asked for the length of the ramp, so we're looking for this side over here. That's going to be our x. Labeling this as be our right angle, so our opposite side, our hypotenuse, and our adjacent, we're using the opposite and hypotenuse, which will be sine. So the sine of 10 will be our opposite, 3.5, over the hypotenuse, which is x. Now to solve this one, we'll move this x over here, which means x is 3.5 over the sine of 10. And we could just plug that in our calculator. They also gave us the ratios, but it's probably easier to use our calculator. And that'll come to about 20.155 or 20.2, which we can see as D. In this next problem, we have some overlapping triangles. What we have here, we have a cliff and a lighthouse. We know how tall this is. So we're viewing this from a point that's 110 feet plus 180 feet, 85 feet. So we're at a height of 195 feet here in our triangle. And looking from that, they're measuring down. They have an angle of depression to the further boat of 33 degrees and the closer boat of 57 degrees. And we want to know how far apart these two boats are. Well, to do this, we need to look at the two different triangles here. I could look at this larger one coming out to boat B, and I could look at the smaller one coming over to boat A. And what I'm trying to find is here is A to B, but if I can find this distance from D to A, and also find up here the distance from D to B, I could subtract those to find out how far this part is. So I'm going to treat these two individually first. The first thing then, looking at where these angles are, this 33 degrees, the angle of depression here, would also be my angle of elevation from B. See, we're following this side right here. And so this would be 33 degrees here. For my other boat, we're looking at the 57 degrees. And so this angle down here, since we're following that same side, would have an angle of elevation of 57 degrees, which we would have in this one here. For both of these, we have a height then of 195 feet. And I'm trying to find this bottom side over here on each of these. And so I can use tangent in each one of these problems in order to solve this. The first one, setting this up, would be the opposite, 195 over dB here. And using that tangent of 33, we come to 300.27. They keep a couple decimals because they want to keep it accurate for later. For the next one, CAD, we set it up the same way, 195 only, this time over DA, and we're using 57 degrees. Working that out, we end up with 126.63. So putting that together, we want the long one minus the short one to give us the distance between the boats, AB, so the 300 minus 126, and that comes to about 174 feet. And they wait to round this till they get to the end just to make sure that their answer is fairly accurate. And one way we can do this, and we'll probably do this during class times, go outside and measure some angles of elevation with a simple tool like this. Now it might not be very accurate. We have a weight hanging here by a string, and we're going to look up here so that we're lining up our sight here with whatever we're trying to find the height of. So in this one we're looking up a tree. We would find the angle of measurement here by looking at our protractor, and we could figure out our angle of elevation.